Okay, Algebra 2 Skills number 34, Exponent Rules, which is a very important little section and one that we need to know for many tests. First, some definitions. 2 to the third power it means 2 times itself 3 times. And of course, it's 8 here. The 2 is called a base, the 3 is called the exponent, and 8 is considered to be a power of 2. So you know your definitions. There are a long list of rules. These are the most common. I'm going to use numbers here instead of just letters. So x squared times x cubed. Here you are multiplying powers. In that case, you add your exponents. If you are raising a power to a power, you should multiply exponents. And these two get mixed up a lot. So add exponents here, multiply on 2 there. If you are dividing powers, you subtract exponents, and a lot of times you don't see x to the first. I put it just to demonstrate here. And stemming off of property 3, we have property 4. Anything raised to the 0 power except 0 itself is 1. Okay. Fifth rule, anytime you raise an exponent or have a negative exponent, that exponent can be made positive by going to the bottom of a fraction. So I didn't actually write the 1 that time, but that 1 becomes positive when you put it on the bottom of a fraction. Okay, so if this were x to the negative 2, it would become 1 over x squared, for example. We'll see this in a minute, some examples. Okay, if you are multiplying with different bases and you're raising both to a power, then you can, in a sense, you can distribute or give both the 2 and the 3 that power. So 2 times 4 is 8, 3 times 4 is 12. This is a combination of really property 2 again, but just goes to show if you're multiplying in there, you can give both of them the power. Same is true when you divide. You can give both the power. But when you're, so I made this red because this is not true. When you're adding or subtracting, you cannot distribute the power. So be careful there. So several examples. Here we're just multiplying. Now these are not exponents, so you're just going to multiply those. 2 times negative 6 is negative 12. But when it comes to the exponents, you add those in the situation. Remember, you only can add when you have the same base. So 2 times 6, negative 6 is negative 12. 4 plus 9 is 13. 2 plus 1, there's an understood 1 there. As we've already mentioned, that's 3. Okay, a second example. So here you're raising this to the second power. And something that often gets missed here is neglecting the 3. Remember, this is 3 to the first. You multiply exponents in this situation. You don't multiply a number or a coefficient times an exponent. So there's no 6 here. It's a 1, an understood 1 times 2, which is 3 squared. Again, 5 times 2 is 10, 7 times 2 is 14. I didn't do anything over here yet. And here's your answer. 3 squared is 9. 9 times 4 is 36. 10 plus 2 is 12. 14 plus 4 is 18. So you have to be careful with when to do what here. Okay, when you're dividing, again, the coefficients, there's no rule on that that's new. You just do what you've always done. So 6/9 is 2/3. And otherwise, you subtract if you have the same base. So 4 minus 3 is 1. Again, we don't write the 1. 2 minus 10 is negative 8. Okay, so we have a negative exponent. So remember what to do there. That goes to the bottom. So notice you already had an established fraction, the 2/3. To be written on the side of a fraction is equivalent to be written on top of the fraction. So that f, since it has a positive 1, goes up top. That g, however, because it's negative, it goes to the bottom. Now, a lot of people will bypass this middle step. They'll think like this. They'll just say, well, 6/9 is 2/3. And wherever the exponent is larger, that's where it's going to end up. In other words, if you have the larger exponent on top, let me go back to that. So it ends up on top. G has larger exponent on bottom, so we can kind of subtract backwards. 10 minus 2 is 8, and just go ahead and proactively put it on the bottom instead of ever writing negative 8. So whether you want this step or not is up to you. Fourth example. When you have a negative exponent, what's best to do here, if you have a negative exponent on the outside, is just go ahead and make that positive. And as we discussed before, anything that's negative can be put on the bottom. Well, if it's already on the bottom and negative, you can put it on the top. So you can just reverse it. So if we flip the fraction upside down, it makes that negative exponent turn positive. At this point, you have a choice of go ahead and give everything the 2, or go ahead and simplify on the inside and then do the 2. I'm going to simplify first here. So 12 divided by 3 is like 4 over 1. Okay, so that's the reason 4 is on top, is because it's 4 over 1. Like we said before, I'm going to skip the negative exponent step. I'm just going to say 6 minus 5 is 1, so I'm going to go ahead and put C on the bottom. Meanwhile, you only have D on top. Don't forget the squared there. Okay, so 4 squared, remember, it's 1 times 2 is 2, so 4 squared is 16, 3 times 2 is 6, and then this 1 times 2 is squared. So a lot going on there. Example 5 seems simple, but I feel compelled to put this one in here because sometimes people make a mistake. They'll add exponents. That's usually not a problem, but they'll think that you're also supposed to multiply. But when you have the same base here and it's all numbers, you retain that base. You don't multiply the bases together. Okay, so that would be 2 to the 17th power. They get that mixed up with the first example where you had 2 different numbers that you multiply. But here, when you're applying the exponent rule, you hold on to the 2. It's 2 to the 17th is correct here, which is a large number that we won't evaluate. So finally, to get our last example here, just type some loose ends. What happens when you have a 0 exponent in there? What happens when there's a negative already on the bottom? We've kind of already mentioned that. What's going to happen when we go straight to our answer here is that this a, the 0 power, just becomes 1, so it's just gone. You don't have to worry about it. And that negative can be put on top, or you could just simply apply the exponent rule here. 2 minus negative 4 is the same thing as 2 plus 4, which is 6, which is on top now. Remember, the larger exponent is on top. 2 is bigger than negative 4, so B ends up on top. 5 minus 2 is 3. Now, in a situation where the denominator is completely canceled, it becomes unnecessary to write. But if you have an example where the numerator becomes vacant, you would have to put a 1 there. So there's some exponent rules.